In this pencast, we're going to be learning how to write the equations for conic sections. So part 1 says, write an equation for the parabola with vertex 1, 1 and directrix x equals 3 over 2. Alright, so we have a parabola drawn here, and the axis of symmetry, focus, and directrix are labeled. So the definition of a parabola is, a parabola can be defined as a set of all points in a plane that are the same distance from a given point, called the focus, and a given line called the directrix. Alright, so if you look at points A and B in this picture, you can see that they're the same distance from the focus, and their vertical distance is the same from the directrix. Alright, so the first thing we can see is that our directrix is x equals 3 over 2. That means that instead of opening vertically, like this parabola in the picture does, our parabola opens horizontally. Alright, so now that we know that the standard form for a parabola that opens horizontally is going to be x equals a times y minus k squared plus h. Alright, so we know that the vertex is defined as h comma k. Alright, so far that means that we have x equals a times y minus 1 squared plus 1. Alright, so our goal here is to find a. So the other thing that we know is that the directrix is going to have the form x equals h minus 1 over 4a. Alright, so we need to solve this equation for a. So we know that x equals 3 halves because that's given to us in the problem. So now what we should have is 3 halves equals 1 minus 1 over 4a, since we know that h is also 1. Alright, so the first step we want to do is subtract 1 from both sides. And that's going to give us 1 half equals negative 1 over 4a. Alright, so we're going to move over here now. So the next thing we're going to do is multiply both sides by 4a to get rid of that 4a in the denominator. So we're going to end up with 4a times 1 half is equal to negative 1. Alright. So now we're going to simplify that to 2a is equal to negative 1. So we're going to divide both sides by 2. We'll end up with a equals negative 1 half. Alright, so now that we know that, we should be able to write our equation. So our equation is going to be x equals negative 1 half times y minus 1 squared plus 1. So that's the equation for a parabola with vertex 1, 1 and a directrix x equals 3 halves. The next problem says, write an equation for the circle centered at negative 2, 1 with a radius of 3 units. So we know that the general form of the equation for the circle is x minus h squared plus y minus k squared equals r squared. Alright, so let's start with r. So we know that in our case r is equal to 3 units. So that means that if we plug that into our form, we're going to have x minus h squared plus y minus k squared is equal to 3 squared. 3 squared is 9. Alright, so now we know that the vertex is going to be h comma k. So we know that in our case h is equal to negative 2 and k is equal to 1. So when we plug those into our equation, we end up with x minus a negative 2 squared plus y minus 1 squared equals 9. So minus and negative 2 is the same as plus 2, so we're going to end up with x plus 2 squared plus y minus 1 squared equals 9. And that's our final answer. So that's the equation for a circle centered at negative 2, 1 with a radius of 3 units. The last problem says, find the foci for the ellipse x squared over 9 plus y squared over 25 equals 1. So I have an ellipse drawn here, and I have the points A, B, and C labeled. So the definition of an ellipse is that it's a set of all points in a plane such that the sum of the distances from two fixed points is constant. These 2 points are called the foci of the ellipse. So the foci are the points at point C. So we know that A is going to be the vertex, which is the larger number. So we know that what we have here is the form x squared over b squared plus y squared over a squared equals 1. Alright, we know that because 25 is bigger than 9, so the 25 has to be the a squared. So this means that we have a vertical ellipse. Alright, so in a vertical ellipse, we know that the foci are at points 0, C and 0, negative C. Alright, so how do we find C? Well, as you can see in the picture, we have a right triangle with A, B, and C. So we're going to do a little Pythagorean theorem. So we know that this relationship is true. C squared is equal to A squared minus B squared. Alright? So in our problem, A squared is 25. So A squared is 25 and B squared is 9. So we should be able to plug those in and solve for C. So what we have now is C squared equals 25 minus 9. That's the same as saying C squared is equal to 16. So if we take the square root of both sides, then we get C is equal to 4, which means that the foci of this ellipse are at 0, 4 and 0, negative 4. And that's our answer.